I'm CK. I reached my hand into my bag of Mitch Electronics kits and I pulled out electronic dice kit for tonight. So we'll take it apart. We'll open it up, take a look at the parts, look at their webpage, which is usually really good on theory and implementation, and put this thing together. And I hope you have a Merry, Merry Christmas. I'm CK. I reached my hand into my bag of Mitch Electronics kits and pulled out electronic dice kit for today. So we'll take a look at what's in it, look at the web page, which is usually pretty rich in theory and implementation, put it together and play with it. And I hope you enjoy the video. Here's the bag. Let's see if I can get the bag open without cutting it open. Maybe. Oh, and there's a QR code to the build guide right here. So we'll get that up in a little bit. See what we got here. Bunch of stuff. That's everything out of the bag. Oops, don't get rid of it yet, because you gotta zap the QR code. Silly person. 9-volt snap cap, some 104 caps, capacitors. Here's the circuit board. Circuit board is, again, good quality. They use good quality manufacturers on their circuit boards, and they're all through-hole plated, which is really nice. No values on the board, which is why we have to go to the QR code. Here's LEDs in a dice array. Inrush or current limiting resistors for those LEDs. Then we've got 1, 2, 3 ICs, which is why we have the decoupling caps we have. A couple of transistors, a bunch of resistors, a switch which says roll on it. Power in there. And looks pretty straightforward. Mitch Electronics 2022. So let's see what chips we got in here. We've got a CD 4017BE, which I think is a counter. And here we've got a NE555, so that's a 555 timer, which you should know as much as you can about, because they're everywhere. And there's another 555. So we've got two 555 timers, some LEDs, sockets. Here's the roll switch. Click, click. Two switches. Where's the other switch go? Might be a power switch, but I don't see a place for it. Did he throw an extra switch in accidentally? I think he threw an extra switch in accidentally. Oh well. And some resistors. Again, there's going to be all the ones that go to the diodes. LEDs are going to be the same value. And we'll put this guy together. So I brought up the web page, and as is usual with Mitch Electronics kits, it's got a great schematics. It's got a simulator showing what it's doing. Tells you how it's working with the two 555 timers, one monostable, the other astable, which I recommend you go look at an online lesson about 555 timers and then play with them, and you'll see what that all means. And the other IC is the 4017 is a counter, as I thought, so it's going to trigger by the monostable, by the counts coming out of the 555s. It's going to count up inside the timer chip and light various LEDs as is appropriate to give you the numbers on the die. And as is typical of Mitch Electronics also, they don't actually give you step-by-step instructions. they give you put resistors on, put the IC sockets on, put the caps on, not specifics as to where and so on, because you just pick that up from the parts list. So we're going to start with 330R, or 330R, 330 ohm resistors. So that'll be orange, orange, brown. And we'll do one of them live here to start to see how the board takes solder. R6, R7, and R8. R6. Okay, you should probably leave about a millimeter away from the body of the resistor when you bend your leads. I'm going to put all three of these in and then just solder one up live. And again, since it is through-hole plated on the board, we can solder it. Take a look. The solder is weeping through the holes, so we get a good electrical connection that is not going to corrode. So there's those three, and not much more to say about the resistors than we've already said. So I'll put the video into fast playback and no commentary, and you can enjoy resistor time. And that's resistor time for this kit. I'm going to do the diodes next. Oh, and by the way, the 10K resistors, his picture here doesn't really, the third band is supposed to be orange, but it's looking pretty muddy brown on this picture. So just don't be confused. We've got black stripe on the diode and a white stripe on the circuit board that shows you how to put it in line with the correct polarity. Now we'll put all the sockets on. I think I'm going to try and put them all on at once. So we'll set them all in with the notch in the socket matched up with the notch printed on the circuit board. Now I'll take my index card, hold them all in place, put it down, slide the index card away, and we're all good. And they're going to be all flat because they are the tallest thing on the board, so I don't have to worry about having them cattywampus. Now we'll do some capacitors, all the 104s, decoupling caps for these chips, and again I don't try and rip them out of the paper tape, I just cut them out. You'll do more damage trying to pry them free of the tape than you will by simply cutting them out. And when you get a bunch of 104, a tenth of a micro, 100 nano, whatever you want to call them, you can make a pretty good assumption that they're decoupling caps which are going to go very close to the integrated circuits because they provide a little bit of isolation, get rid of signal noise, provide a small bit of power buffering either when the power comes in too hot or when there's a slight sag on the power traces. These little caps will provide that extra power. So they're doing two real jobs. And they're as close to the IC as possible based on the board design, because another part of their job is to deal with some of the issues around power traces like inductance. That's all those little fellas. Now we'll put on the two transistors, which, as you can, if you look at the schematic, the switches, the transistors get turned on by the switches, by the switch, and that's what starts making the 555s do their thing. And these are both the same, aren't they? Of course they're both the same. They came on the same strip. Let me double check though. Yeah. 3904s, NPN transistors. And we will make sure the flat side of the transistor is correctly oriented with the flat side of the printing on the board. Electrolytic cap, since I cut it out of the tape, I can't see which leg is the long leg. However, the white stripe on the back matches the shaded part of the printing on the circuit board. I'll also put the switch on board. Now with the LEDs, it's a little more, you have a little more of a risk of doing something wrong. When you clip them out, you don't have the long lead, but just before you clip them out, make a note of how the flat side, which is the negative side, looks and feels, because then you won't get confused. And these LEDs have really pronounced flat sides, which is nice. Sometimes you're running your finger along the LEDs and saying, I don't know what's going on here, I can't tell which one's the flat side. So typically, with LEDs, the negative lead, the cathode side, I'm going to put a little piece of foam under here to get these all to rest flat, even though I'm not electrolytic, oh, I know what I'll do. I'll switch over to the other side of the board. That electrolytic is holding it up a hair. Okay, I could tell I didn't get them all straight, and they're not, so I only did one leg. So I will just heat the one leg I did, push on it with my finger to get it flat on the board. Now we'll put the power connector in. Red to V plus V, black to 0V or ground or whatever you want to refer to it as. Double checking the power, I did get it in correctly. Now we'll put the ICs in, bend the leads a little bit against my workbench side, notch in the chip, goes to the notch on the board and the socket. All the chips with pins went in straight, nothing bent. And the two 555s. They're the same chip, they're just one's set up in a astable fashion, the other's set up in monostable again. Look those terms up here on YouTube or on the web in general, and you'll find some really great tutorials about how a 555 works and why they are used in everything from your phone to your refrigerator, all kinds of things. There we go. Pretty straightforward build. Everything went together rather simply. We did end up with an extra switch and an extra diode, which we'll put in our spare parts box. Now I'll go get a battery and we'll make this thing go. I'm going to turn my overhead light off here to make it a little easier to see this. And I'm using 9-volt battery. In my shop I only use rechargeable batteries for kits like these, because if I didn't, there we go, we've got a 3 showing up. Let me hit the switch. 1, 4, 1, 4, 1, 3, 5, 1, 3, 5, 6. I'm going to long press this and watch it roll and roll and roll. 2, 4. So it seems reasonably random. So that's it. Nice little kit, another nice little kit from Mitch Electronics with a great web page to show you a simulation of it, a great schematic, and some guidance on to how it works. And keep in mind, you can go to the product link that I provide in the description, and you can go to the web page and learn about this without having to buy it. You could watch me build it, or even not watch me build it, and then just go and learn about using a 555 timer in a semi-random type product like this. Another good product, another good kit from Mitch Electronics. And I hope you enjoyed the video.